Okay, we are answering a question about one of the test questions where we were asked to calculate the margin of error and or the confidence interval boundaries. So I've set up places to put all our information, and so let's read through the problem and see what we have here. It says, assume that a sample is used to estimate a population mean mu. Find the margin of error that corresponds to a sample of size 11 with a mean of 36.5 and a standard deviation of 12.3 at a level of confidence 99.9. Report your margin of error accurate to one decimal place because the sample statistics are presented with this accuracy. Okay, now margin of error can be denoted ME, as you see it here, or just the capital letter E, or EBM in the textbook. So margin of error is any of those denotations. And the way you calculate it is you take your critical value times the standard error. So if we are calculating interval boundaries for a population mean, meaning we want to take the sample mean, which is our point estimate, and add a margin of error and subtract a margin of error to create an interval of estimations for the population mean, then we will use this margin of error. So we will just take for the left boundary, the lower boundary of our confidence interval, the sample mean minus the margin of error, and for the upper boundary, the sample mean plus the margin of error. So our steps are to calculate the critical value and the standard error so that we can multiply them to get the margin of error. Once we have the margin of error, we will subtract it and add it to the sample statistic. All right, so this question actually only asks us for the margin of error, but we'll go ahead and do all of the steps as if we were asked to give the entire confidence interval. So as I'm reading the problem, it tells me about a sample that is going to be used to estimate this population mean. We want to find the margin of error with a sample size of 11, and talking about that sample still, a mean of 36.5. So that is our X bar. And our sample standard deviation, because again, when the standard deviation is mentioned here, it's in context talking about the sample of 11 with a sample mean of 36.5 and a sample standard deviation of 12.5, or 12.3 rather. And this is important because if it's S that we know and not sigma, then we will not be doing a Z distribution to find our critical value. We'll be using the T distribution to do that. Okay, so let's find our critical value. If we make a sketch, remember that confidence intervals are always two-tailed. And so that means that your significance level is split up evenly into both sides, and you have two critical values that are the same distance from zero. One is negative and one is positive. So I have my confidence level given in the problem as 99.9%. So as a decimal, that's 0.999. That makes the area total in both tails 1 minus the confidence level. And in each single tail, I'm going to have half of that. Okay, now to find the positive critical value, and why does it need to be positive? Because I'm calculating a margin of error, which needs to be a positive distance. So we are interested in this right critical value here. Now there's two ways to go about finding its value. You can either use symmetry, meaning you find the negative one and then just change the sign, or you can get the area all the way from this boundary all the way to the left and use that. So we'll do it both ways. First, I'll show you how to use symmetry. That's the way I normally like to do it. So I'm going to find a boundary under the T distribution, which means I'm going to be using T dot inverse. T dot inverse requires a left probability, so I'll feed it the left tail, and then it wants degrees of freedom, which is n minus 1. So that's 11 minus 1 will be 10. And then notice that I get a negative answer here. And if I use that in calculating my margin of error, I'm going to get a negative margin of error. So watch what happens. So my standard error is the sample standard deviation divided by the square root of n. So I'm using the central limit theorem here for using sample means. And now that I have a standard error and a critical value, I can calculate my margin of error using that critical value times the standard error. And notice that I get a negative margin of error. So what happens when I calculate my confidence interval limits, taking my sample statistic minus the margin of error and my sample statistic plus the margin of error? What's going to happen is notice that my boundaries are not in order from least to greatest. So my interval won't make any sense. It's supposed to be the other way around. It's supposed to be 20.4 up to 52.5. We're rounding this to one decimal place to match the sample statistics given in the problem. All right, so you can see that doesn't make sense. This has to be positive. So you can either put an absolute value on that, or what I do is if I need a critical value that's positive, I put an absolute value around the t inverse function. That way it's always positive. Another way of approaching this is if you use the left area all the way from the positive critical value. So what is that area? Well, it would be 1 minus this little tail over here, right? Or rather, 1 minus this right tail. So the area from the left, all the way from the left, from the critical value that's positive on the right, is 1 minus the right tail. And so I could use that to do t dot inverse on my large left area all the way from the positive side with n minus 1 degrees of freedom. Notice I get the same result that way. And now that my margin of error is calculating as a positive distance, I can see that my confidence interval boundaries actually make sense. So the margin of error that we were asked for in this problem was 17. Now mine's rounding to 16, so let's see why that might be. Did I put anything in wrong anywhere? I don't think so. 36.5, 12.3, sample size of 11. That makes my standard error equal to s divided by the square root of n. That should be the square root of n here. And now it looks right. So I've got 17 now. All right, now a similar problem here. If n equals 15 and x bar is 49 and s is 5, construct a confidence interval at a 90% confidence level. Assume that the data come from a normally distributed population. Okay, so it came from a normally distributed population, but our sample means will follow the normal distribution. But since we don't know the true sigma, we are using the t distribution. So nothing's really changed here except the numbers. And you can see that my boundaries automatically updated when I changed my sample information and my confidence level. All right, then question 46, we have a sample size of 16 and x bar of 41, sample standard deviation of 3, and calculate the margin of error at 0.98. Okay, so once again, everything recalculated, and when I round this to 2 decimal places, I get a margin of error of 1.95. Here's another one. You measure 37 turtles' weights, okay, so that's n, and find they have a mean weight of 47 ounces. Assume the population standard deviation is 10.4. Okay, so now this is no longer the sample standard deviation, this is the population standard deviation. And based on this, construct a 95% confidence interval. Well, now I don't want to use this, okay? I don't want to use this anymore because it's t distribution, which I would be using if I didn't know my true population standard deviation. But I do. So I'm going to be doing a z-test instead. Okay, so now I'll put my confidence level in, find my problem again. My confidence level is 0.95. And now I'll go ahead and find the critical value and calculate the margin of error and the boundaries. So the margin of error will be calculated using this critical value. Once I find it, it'll be equal to the critical value that's a z-score times the standard error. Okay, so right now it's just showing 0 because I don't have anything in here yet. Okay, now to calculate the critical value, we need an area. So the total area in both tails is 1 minus the confidence level. The left tail would be half of that. The right tail would also be half of that. And the area from the left all the way from the positive critical value would be 1 minus the right tail. So I can find my z-score either doing norm.inverse, since it's a z-score, and use the probability all the way from the left with a mean of 0 and a standard deviation of 1, and that's because it's a z-score. Then I get my critical value of about 1.96, and notice that my margin of error has calculated to be 3.4-ish, and my boundaries have recalculated as well, just using my sample mean plus and minus my margin of error here. Okay, so let's just make sure all this makes sense. And we can also find this using, instead of using the left area, I could use the left tail, and notice that it is negative, so that's going to calculate incorrectly. My boundaries are backwards. So if you do it that way, you'll need to put an absolute value around this to make it positive. All right, so now we can see that the answers are supposed to be 47 and 47 plus or minus 3.35. Well, that's because the margin of error is 3.35 that's being added and subtracted, and the original point estimate is 47. So this format of a confidence interval is where you have your sample statistic plus or minus your margin of error.